In this video, we're going to talk about solving rational equations. In other words, we're going to talk about solving equations that involve rational expressions. The first one we're going to do is solve the equation x minus 2 over x minus 3 equals 0. Now, this is an equation because there's an equal sign, and it's a rational equation because there's a rational expression in it, x minus 2 over x minus 3. Well, first what we're going to do is determine any restrictions on x. So in this case, we see, just by looking, we know x cannot equal 3. Now, what we're going to then do, we're going to multiply each side by x minus 3. So when you multiply this left-hand side by x minus 3, you get this expression here, x minus 3 times x minus 2 over x minus 3. And then when you multiply 0 by x minus 3, you get 0 times x minus 3. Now, let's look at the left-hand side. If you've got a factor of x minus 3, multiplying directly a rational expression and one of the factors of the denominator of that rational expression is the same factor of x minus 3, you can literally cross those factors out. What you're really doing there is you're dividing by x minus 3. So you can cross them both out, which is fine, and you're left with an expression on the left of simply x minus 2 over 1, or in other words, x minus 2. Now, 0 times x minus 3 is good old-fashioned 0, and so basically we just have x minus 2 equals 0. Adding 2 to both sides tells us x equals 2. That's the end of the question, except for what it then says. You have to make sure that your answer doesn't conflict with a restriction. If the answer conflicts with a restriction, then it's not a valid solution. So for example, what I mean by that is, early on we said x cannot equal 3. If we get to the end of the question and the answer says x equals 3, our job is to say no, it can't, because early on we stated a restriction that x cannot equal 3. But that doesn't happen in this case. Our answer of x equals 2 does not conflict with the restriction of x cannot equal 3, and so therefore we have a valid solution. The solution is literally just x equals 2. Now suppose you're writing a test and there's an answer box and the teacher asks you for the value of x. Just write x equals 2. Don't write x equals 2 and then also state the restriction x doesn't equal 3. Don't put that. It doesn't make sense to put that in this context because we're asking you what x does equal. We're not asking you to tell us what it doesn't. Okay? Let's do one more here. We have the equation x plus 3 over x minus 4 equals x minus 1 over x plus 2. Now, first thing we're going to do is we're going to state restrictions. So I look at this first rational expression and I say, well, x minus 4 can't be 0, so therefore x can't equal 4. And I look at the second one and I say, well, x plus 2 can't be 0, so that means x can't equal negative 2. So right away, I'm feeling pretty good about myself. Now what I'm going to do is I'm going to multiply the left-hand side by x minus 4 and by x plus 2. And I'm also going to multiply the right-hand side by x minus 4 and by x plus 2. Now you might be curious, why would we do that? Well, check this out. We've got a rational expression of x plus 3 over x minus 4, and we're multiplying it by a factor of x minus 4 and a factor of x plus 2. If you remember what we said earlier, we said if I have a rational expression and one of the factors of the denominator equals a factor that I'm multiplying the whole expression by, basically what's happening is this x minus 4 is in a numerator when it's off to the side multiplying like that, and this x minus 4 down here that I'm circling again, that's in a denominator. We can cross those out. And similarly, on the other side, we're taking this x minus 1 over x plus 2, and we're multiplying it by x minus 4 and x plus 2. Well, same principle. We see we've got this x plus 2 as a factor of a denominator, and we're multiplying that rational expression by x plus 2. We can cross those out. And so what we end up with, if you look at the left-hand side, it's just x plus 2 and x plus 3, both in the numerator. And on the right-hand side, it's just x minus 1 and x minus 4. Okay? And that's what we've written here. Now our job's pretty easy. We really just have to expand x plus 2 times x plus 3. So when we expand it, x times x is x squared, x times 3 is 3x, 2 times x is 2x, 2 times 3 is 6, and then on the right-hand side, x times x is x squared, x times negative 4 is minus 4x, negative 1 times x is negative x, and negative 1 times negative 4 is positive 4. And so x squared plus 3x plus 2x plus 6 literally just becomes x squared plus 5x plus 6. And x squared minus 4x minus x plus 4 literally just becomes x squared minus 5x plus 4. I can subtract x squared from the left and the right. I'm allowed to do that when it's an equation. So what I'm left with is 5x plus 6 equals negative 5x plus 4. I can then add 5x to both sides, and I can subtract 4 from both sides. When I add 5x to both sides, I get 10x. When I subtract 4 from both sides, I get plus 2. So I get 10x plus 2 equals 0. Well, that's like saying 10x equals negative 2, or in other words, x equals negative 2/10, or in other words, x equals negative 1/5. So that's our answer, x equals negative 1/5. But don't forget, check against any restrictions. Early on in the question, we said the restrictions are x can't equal 4 and x can't equal negative 2. So our answer that x does equal negative 1/5 is valid. And so we're good. We just say simply x doesn't equal negative 1/5. Now again, remember, don't say x equals negative 1/5, but then also state x doesn't equal 4 and x doesn't equal negative 2. Don't do that. This isn't a question where you state restrictions. If they're asking you to tell them the value of x at the end of the question, after you've considered restrictions, don't put them in the answer. Okay, one more here. We've got this long expression. So what we're going to do is we're going to factor each denominator. We see x squared plus 3x minus 10 is x plus 5, x minus 2. X squared plus 2x minus 15 is x plus 5, x minus 3. And then finally, we have a denominator of x minus 2 that doesn't factor. Right away, we state our restrictions. Looking at the x plus 5, we see x can't equal negative 5. Looking at the x minus 2, we say x can't equal 2. And looking at the x minus 3, we say x can't equal 3. So here's our lowest common denominator. Okay. Now, we then have this x plus 5 over x minus 2, and it became x plus 5, x minus 2, x minus 3, because we just said that's our lowest common denominator. So ask yourself, what did I multiply x plus 5, x minus 2 by to get x plus 5, x minus 2, x minus 3? The answer is I multiplied by x minus 3. So multiply the numerator of 4x plus 2 by the exact same thing. And that's what we've done. Now let's look at the second one. The second one is x plus 5, x minus 3. It becomes x plus 5, x minus 2, x minus 3. What did I multiply this one by to get this one? And the answer is multiplied by x minus 2. So what do we multiply 10x plus 2 by? The answer is x minus 2. And we do that in the numerator. And finally, this last denominator was x minus 2. Now it's x plus 5, x minus 2, x minus 3. What did we multiply that by? The answer is x plus 5, x minus 3. So what are we going to multiply 10 by? X plus 5 and x minus 3, which we've done, and now that's in our numerator. Okay, so that's our whole long expression. Now, what we're going to do next is we're going to multiply every single term. So that means this first one, and this second one, and this third one. We're going to multiply all of them by x plus 5, x minus 2, x minus 3. And just for a second, let's see the effect of that on the first one. So let's just to show you something. That first one, I know it's getting a little messy, but that first one there is 4x plus 2, x minus 3, over x plus 5, x minus 2, x minus 3. Well, we know we can multiply that by x plus 5, x minus 2, x minus 3. We can multiply it by any non-zero quantity we want, so long as we agree to do that to every one. Well, when we do it to the first one, the impact is we cross these out. And so we're left with just 4x plus 2, x minus 3. Well, the same thing happens with the second one. When we multiply that rational expression by x plus 5, x minus 2, x minus 3, we end up with just the numerator of 10x plus 2 and x minus 2. And finally, that last one, the 10 and then x plus 5, x minus 3 over the long denominator of x plus 5, x minus 2, x minus 3, when we multiply it by x plus 5, x minus 2, x minus 3, we're left with just the numerator of 10 and then x plus 5, x minus 3. The effect of this, everything I'm saying, it got a little messy, but remember this. The effect is this. When you get your equation to where all you have left are rational expressions on both sides, and every rational expression has the same denominator, which we have now. If you look at the bottom, we have just three rational expressions. Everyone has the same denominator. When you get to there, state your restrictions, which we did, and then clear the denominators out. Forget about them. And that's what we've shown on the next line. We've literally just cleared out the denominators and stated just the numerators. Keep the plus or minus in between like they are in the question. So that's a plus. Leave it as a plus. And now just expand this out. So we have 4x squared minus 12x plus 2x minus 6. And then we're adding. We've got 10x squared minus 20x plus 2x minus 4 equals, now we have x squared minus 3x plus 5x minus 15. When we then distribute, we collect like terms on the left-hand side, and we're left with 14x squared minus 28x minus 10. We distribute in the 10 on the right-hand side, and we're left with 10x squared minus 30x plus 50x minus 150. When we collect like terms and gather things onto the other side, we subtract 10x squared from both sides, we get 4x squared. We've got negative 28x. After collecting like terms here, we have positive 20x, but we bring it to the other side and we have negative 48x. And then we've got negative 10 on the left, but we've got negative 150 on the right, so we bring that over and add it, we get positive 140. What we end up with is simply the trinomial 4x squared minus 48x plus 140 equals 0. Okay, so we show that there, but keep in mind you can factor the 4 out. Always try to common factor. So factoring the 4 out, we get 4 and then x squared minus 12x plus 35 equals 0. And that's where we begin the next slide. We can factor out x squared minus 12x plus 35 to x minus 5, x minus 7. So what we really have here is 4 times x minus 5 times x minus 7 equals 0. Well, once you have an equation factored out, and it's just the series of factors, and it equals 0, that means one of the factors equals 0. So when I write this equation, the one that I'm pointing to with the arrow, when I say 3 factors multiplied equals 0, well, that means one of the factors is 0. So either 4 equals 0, or x minus 5 equals 0, or x minus 7 equals 0. Now listen, 4 does not equal 0. No matter what planet you're on, there's no variable there. It can't happen. 4 is not the same as 0. So we're left with just the other two. X minus 5 equals 0. Well, if x minus 5 equals 0, adding 5 to both sides means x equals 5. And if x minus 7 equals 0, adding 7 to both sides means x equals 7. And so we can say x equals 5 or x equals 7. But we still have to remember, always compare to the restrictions. Early in the question, we said the restrictions were that x cannot be negative 5 or 2 or 3. Well, the answers are 5 and 7, so there's no conflict with the restrictions. So the valid answer is x does equal 5 or 7.